Our objectives are to define ratio and proportion, reduce ratios to lowest terms, use proportions to solve for an unknown term, and then identify ways that ratios and proportions are used by healthcare workers. Ratios. So, a ratio shows a relationship between like values. Ratios ask the question how much of X is present when compared to Y. For example, suppose that a doctor's office has 3 male doctors, 5 female doctors. The ratio of male to female doctors is 3 to 5 because you got your 3 male and 5 females. Ratios can be expressed in several forms. The ratio that compares male doctors and female doctors can be written in the following ways. You got 3 to 5, 3 with the colon 5, or 3/5. A ratio shows a relationship between like values. It's true. A doctor's office has 3 registered nurses and 7 licensed practical nurses. Which of the following is the correct way to express the ratio of registered nurses to licensed practical nurses? So it's all of them. Reducing ratios. So a ratio can be expressed in the form of a fraction. Fractions must be reduced to lowest terms. For example, 9/15 is not a correct fraction because both the numerator and the denominator are divisible by 3. So when you reduce it, it'll be 3/5 because 3 goes into 9 3 times, it goes into 15 5 times. Likewise, ratios must also be reduced. Suppose an emergency room has 4 unoccupied beds and 8 occupied beds. The ratio of unoccupied beds to occupied beds is 4/8 or 4 to 8. However, the ratio of 4/8 is not written correctly because both the numerator and the denominator are divisible by 4. Therefore, the ratio of unoccupied beds to occupied beds should be written as 1/2 or 1 to 2. In other words, for every 1 occupied bed, there are 2 occupied beds. So that's kind of like how our grading system works with how many major to minor that we have to give y'all. So it's like a 1 to 2 ratio. So for every major grade we got it has to be 2 minor grades. And that's where they get the numbers from. Which of the following ratios is reduced to lowest terms? Right. In one day, a doctor saw 6 female patients and 8 male patients. What is the ratio of female to male when reduced to lowest terms? Right, 3 to 4. Because you got your 6 to 8, and then it's divisible by 2, so 3 to 4, divisible by 2. Solution strength. Alright, so ratios are often used by healthcare workers to determine the strength or concentration of a solution. A common cleaning solution is a mixture of bleach and water in a 1 to 2 ratio. This means that for every 1 part of bleach, there are 2 parts of water. This relationship applies to any unit of measurement such as 1 cup of bleach and 2 cups of water, 1 gallon of bleach and 2 gallons of water, 2 liters of bleach and 4 liters of water, half a quart of bleach and 1 quart of water. So if you ever like did some kind of DIY project or some like if you see some cleaning solution that people might use for like cleaning hardwood floors or something like that, they'll always give you like the measurements for the solution like with a ratio. It'll be like 1 part's water or 1 part's bleach, 2 parts water. That's what they're meaning. Oh, I keep just saying. Oh. Healthcare worker is told to mix a solution of ammonia and water in a ratio of 1 to 3. Which of the following demonstrates this ratio?
This one will answer that.
What?
Just stay quiet.
I mean, it's life. You're gonna be wrong sometimes.
I'm just gonna stop.
Oh, okay, then you answer one question wrong, and now everything's shut down. All right, so we're gonna match the reduced ratio to the correct description. 3 doctors to 12 nurses. 8 operating rooms to 40 surgeries.
320.
Huh?
I don't know how. I know 320.
No, it's gonna be 9 laboratories to 15 lab technicians.
Yeah, I'm coming.
15 healthcare workers to 100 patients. 9 ambulances to 27 emergency medical technicians. Right. So do y'all see that? Do y'all really see it? Don't just, because if you're looking at it, so you know there's 3 to 12, so it's basically like 3, 12. We know we're gonna break it down into the lowest possible terms because 3 goes into itself once, into 12 4 times. So it's like just simplify it. So that's all they're doing. They're writing it like this, so 8 will be here, 40 will be here. They look at it, they see they have light terms, so they'll simplify it. So it's just like you're breaking it down to the lowest terms. Because you can write it like that, go ahead and write it in the ratio form, write it in a fraction form, however, then you just have to simplify it. Y'all heard from Jemiah? When she come back?
I don't know, but I heard somebody at work.
You saw
Well, I
her?
don't work with. I saw her working on this and food. She's not coming back.
She not? Where she work at?
Late room. Well, it's a train.
Proportions.
Alright, so a proportion is an equation that shows equality between two ratios. So the proportion 2 to 3 to 4 to 6 literally means that 2 is related to 3 in the same way that 4 is related to 6. So in a proportion, the two middle terms are called the means. The two outer terms are called the extremes. So you got your means, and then you got your extremes. To determine if a proportion is equal, you'll follow this rule. The product of the means is equal to the product of the extremes. And the proportion 2 to 3 to 4 to 6, the means are 3 and 4. The extremes are 2 and 6, because 3 times 4 equals 12, and 2 times 6 equals 12. The proportion is equal. Proportions are often used to solve for an unknown term. Suppose a proportion was written 2 to 3 to x to 6. X is the unknown term. So you'll follow these steps to solve for x. You'll multiply the mean, so that's 3 times x. So you know your means are in the middle here. In the middle. And then you'll multiply your extremes, which is 2 times 6, which equals to 12. And then you'll set up the equation to solve for x. So you'll set it up, the product of the means is equal to the product of the extremes. So 3x equals 12. So you'll solve for x by dividing both sides of the equation by the number in front of the x. So 3x divided by 3 equals 12 divided by 3. So x is going to equal to 4. So do y'all see how that works? Okay. Alright, so a proportion is an equation that shows the equality between two. True.
Oh.
Two ratios. In a proportion, what are the two middle terms called? They're called the means. Those are the two numbers in the middle.
I didn't look at it. I thought you actually was it a true.
Parallel proportions.
Alright, so to set up a proportion correctly, the equation must be arranged in the proper order. So consider the following model, A to B to A to B. So this model shows that the equation is parallel. So the first and third terms are alike. So like terms here, A and A, like terms here, B and B. And the second and fourth terms are alike. For example, suppose that in the first part of the proportion, the A term is milligrams and the B term is tablets. In order to set up the proportion correctly, the A term in the second part of the equation must also be a value of milligrams. So likewise, the B term in the second part of the proportion must be a value of tablets. So all proportions must be parallel.
Set up parallel.
Alright, so suppose a lab tech is able to complete 9 tests in 4 hours. How many hours will it take the technician to complete 36 tests? Follow these steps to set up a parallel proportion. So we're going to identify what is known. That's our first step. So we know that the tech can complete 9 tests in 4 hours. Okay, so the first part of the proportion is 9 tests to 4 hours. So now we're going to look at what our unknown term is. So we don't know how many hours it takes to complete 36 tests. So the unknown term is the number of hours. This term is called X hours. So we'll set up the proportion by following the A to B to A to B model. You know that the first part is 9 tests to 4 hours. Now we're going to add the second part so that the equation reads 9 tests to 4 hours to 36 tests to X hours. Because you know X is what we're trying to figure out. And we know the things that we know that it takes 4 hours to do 9 tests, and we want to know how many hours it'll take to complete 36 tests. So X is going to be our hours. Alright, so solving the proportion, so we'll multiply our means. So remember, our means are the two that's in the inside. So you got 4 times 36. That's going to give us 144. Then we're going to multiply our extremes, which we know is 9 and x. So 9 times x equals 9x. So we're going to set up the product of the means so that it equals the product of the extremes. So 9x equals 144. You'll solve for x. And it's 16. So the proportion will now read 9 tests to 4 hours, 36 to 16 hours. It will take the lab tech 16 hours to complete 36 tests. Alright, all proportions must be parallel. Which of the following proportions is parallel? Oh, we want to answer again. So the last one is parallel because if you look at it, you got your milligrams and then you got your tablets. If you look at the other ones, it's not parallel if you look at them. All right, 3 nurses to 15 patients. Huh? 1 to 5. 9 surgeries out of 27 surgeries. 1 to 3. 12 green gowns to 15 blue gowns. 4 to what? 17 days out of 31 days. Huh? I'll be whispering. 8 patients out of 22 patients. She think it's what? That's right, 4 to 11.
Don't be scared. Chill out.
A doctor can complete 3 exams in 2 hours. How many exams can the doctor complete in 5 hours? What y'all think?
Two times five.
Hmm?
You gotta 3 to 2, and then 5 to X. 2 times 5 is 10. 10 times 3. This is a B or D.
Right.
What was it? D.
Mm-hmm. To create a dental mold, a dentist must add 45 milliliters of water to 100 grams of plaster. How much water should be added to 250 grams of plaster? So you got 45 to 100 on one side, 45 milliliters to 100 grams. So on the other side, we know we got 250 grams in X.
So 45 to X. 1, 2 to 10.
45 to 100 what?
45 to 100 to X to 50.
Okay. So
100 X. No. Yeah, 100 X. 45. That's too fast.
112.5. 112.5 milliliters of water. You're asked to create a solution that is 3 parts water, 2 parts bleach. You have 4 liters of bleach. How much water should you add? So we got 3 to 2. You have 4 liters of bleach. Right.
Lesson summary.
Alright, y'all line up for lunch.
What you'll learn.
Let me see you.
Alright.
You ready to teach me?
Thank you so much. Alright, so our objectives for this part are to explain why estimating is important to healthcare workers and estimate by rounding and averaging.
Estimating.
Alright, so healthcare workers must be careful when making mathematical calculations. It's possible for errors to have harmful effects. For example, miscalculating a medication dosage for a patient can lead to further sickness or even death. Even simple errors such as copying a wrong number, placing a decimal point incorrectly may create serious problems. One way to reduce the number of mathematical errors is to estimate what the results of a calculation will be. Estimating is figuring out an appropriate or approximate answer and then judging if the result of the actual calculation seems reasonable. Many estimates involve mental mathematics that allow healthcare workers to determine when an answer looks out of place. Healthcare workers can use several strategies when estimating. 2 of these strategies are rounding and averaging. What is estimating? All of the above. So it's going to be calculating an approximate answer, judging if a calculated result seems reasonable, and determining when an answer looks out of place.
Rounding.
Alright, so mental calculations are easier when numbers are rounded to a multiple of 10. For example, suppose a supply clerk needs to order 24 CPR masks for each of the 9 floors of the hospital. The supply clerk can round 24 down to 20 and round 9 up to 10. It is much easier to mentally multiply 20 times 10 than it is to mentally multiply 24 times 9. At a glance, the supply clerk can see that about 200 CPR masks must be ordered. Although this figure is not an exact calculation, it provides a starting point. Later, the supply clerk may determine that the exact number of CPR masks needed is 216. By comparing the estimated figure of 200 to the actual figure of 216, the clerk may judge that the calculation was done correctly. The actual answer is reasonably close to the estimated answer. So they just estimated by using 10, 20 and 10 that they would need 200 CPR masks. Mental calculations are often easier when numbers are rounded to a multiple of 10. Rounding gives an exact calculation.
Averaging.
So an average is a number that represents a set of numbers. For example, suppose that it takes a volunteer 5 minutes to change the sheets on one bed, 8 minutes to change the sheets on a second bed, and 8 minutes to change the sheets on a third bed. The volunteer can estimate the number of minutes it will take to change the sheets on a fourth bed by finding the average in this set of numbers. So you'll follow these steps to find the average. So you'll add the numbers in the set to find the sum. So 5 plus 8 plus 8 equals 21. You'll divide the sum of the divide the sum by the number of items in the set, which is 3. So you have 5 minutes, 8 minutes, and 8 minutes. So 21 divided by 3 is 7. So identify the answer. The answer is 7 minutes. So it takes the volunteer an average of 7 minutes to change the sheets on a bed. Therefore, the volunteer can estimate that it will take about 7 minutes to change the sheets on the fourth bed. Now suppose the supervisor asks the volunteer how many beds he can change in 1 hour. The volunteer can estimate again by using the average. He knows that it takes an average of 7 minutes to change the sheets on one bed. By dividing 60 minutes, which is 1 hour, by 7 minutes, he can determine about how many beds can be changed in 1 hour. So 60 divided by 7 is 8.57, which rounds up to 9. The volunteer can change the sheets on about 9 beds in 1 hour. All right, so what is a mathematical average? Right, a number that represents a set of numbers. So, all right, a nursing student is budgeting for college. He spent $325 on books for the first semester, $460 on books for the second semester, $395 for the third semester. How much should he budget for books for the fourth semester? Round to the nearest whole dollar. So you're going to do 325 plus 460 plus 395 divided by 3. I don't have my calculator in front of me, so I can't do it.
I hate math.
This is simple math.
395 divided by 3.
No. 325 plus 460 plus 395.
I'm just saying.
Divided by 3. You're going to round to the nearest whole dollar.
Round it to the nearest whole number. Can't be right.
325. Close. Okay. 400. Oh, 394.
That's no.
Oh,
What's the answer?
393.3. Oh, I'm checking.
Round to the nearest whole dollar. Yep. So if you add these 3 numbers and divide by 3, because you got 3 numbers, that's going to give you your average. So it came up to 393.3, I guess. So if you round it to the nearest whole dollar, it's going to be 393. A technician ran several blood tests this morning. She completed 13 sets during the first hour, 19 not sits, 13 tests during the first hour, 19 tests during the second hour, 14 tests during the third hour, and 16 tests during the fourth hour. What is the average number of tests a technician completed in 1 hour? Round to the nearest whole number.
13 plus 9 plus 14 plus 16 divided by 4. 16.
Alright. If the technician works 3 hours this afternoon, about how many tests will she complete? It takes 1 hour to do 16 tests.
48.
Alright. So 16 times 3. Alright, so during her first week of work, a physical therapist estimated that therapy sessions should last about 30 minutes each. However, the sessions take longer than expected. On one day, the sessions lasted for 47 minutes, 53 minutes, 32 minutes, 50 minutes, and 45 minutes. How long should the physical therapist expect to spend at a therapy session? Round to the nearest whole number.
Forty-five. 45. This one I'm saying.
I love that.
You know,
I said they love saying that. That's what I'm
Lesson
saying.
summary.
Alright, so I gave you a paper, a worksheet that has ratios and proportions, and it also has estimating on one side. So I want you to complete those. I'll put the ratios and proportions, like how you set it up. I'll put that back on the screen for y'all.
Lesson
For those of you that need it.
Set up parallel proportions. Set up parallel proportions.
Yes.
Do you have the iPhone videos in your class?
Yes.
Can you send her down to check out?
Okay.
Thank you. Are you going to next class?
I guess so if you leave. Huh? Oh, alright.
Bathroom.
That's why we're smarter.
get done with it, you can put it in a fifth period inbox on the left side. Okay. You do left side. See your name on it. Tavia or Brita, y'all want y'all's CPR card printed and laminated?
Yes.
Can y'all email it to me?
Okay.
I need you to email me the PDF because if you just do an image, it's gonna be blurry. Do the wallet card. Mm. So Wednesday, W will do the second half of your project. Doing that thing.
Yeah, you should get on my nerves every day. I'm
Wait,
glad
your eyes don't hear me.
because I'm here to
I did. I said she missed you like Shamari missed you. Who missed who? Who missed you?
Oh, never
I don't
mind.
miss him. I do not.
Me?
I don't even know. We don't mean each other.
I don't even know who that is.
You do know who she is.
I don't.
Oh Lord. Let me tell y'all like I told my first kid. That's the reason why I got gray hair. That's why I got hair appointment now. Shania, CJ, tomorrow. We gave you. But that ain't that twice.
Me here. Miss Harris, you ain't even seen me, so I give you girl.
So like she's been out a week and she just keeps talking about.
Baby, I've been out 3 weeks.
What kind of COVID y'all had?
This week would
Y'all
have
wasn't that long.
been this week would have been the 4th week. They should have entertained my phone.
The phone did.
My phone is dead.
It is on.
But there you
Gotta go get this gray couple.
yeah, like my mom said the same thing. She comes to us at a hole. Everything y'all get old, I'm like,
You already old?
I'm talking about everybody that keep doing gray hair.
I know some teenagers that got gray hair now.
Who?
I know some of them in my classes.
CJ.
Oh, that look good.
You ain't supposed to what?
CJ, you got gray hair right now.
I don't know. I don't know about this COVID.
No, you don't talk about it when you feel it. Come on.
That's not my word.
Some more gonna come in there, some more gonna come out.
No, a whole more than what you have on.
Oh, gray hair.
Uh-huh.
Oh, I don't pull it. It's just there.
I tell you that.
You
I
died.
mean,
Back up.
you finna die since you.
I don't be dying.
I just want to get some color.
It's
I ain't had it since last time. Why do you have her with purple?
I don't
I
put no
Ouch, that hurt.
No, I purple cute, but
Oh, this one finna put in the wrong one.
Installed. Installed.
Give me this.
So some of them folks I see and I'm like,
Yeah.
No, don't run a burnt the hot dog.
I'm
You doing great again.
I'm like, girl, don't do that. I'm like, hey, not one time. I was like, oh, I told everything.
I already got one in the cart. Well, now. I was at the old one.
You weren't thinking about no glue till I brought this glue. I need a piece of glue. Cause I got to do these things. I
It's gonna cost that much.
So,
You trying to get 14? You might as well go ahead and get the big 114.
y'all have to be back in the building.
no.
Why?
I missed my 5 weeks off.
I like dinner.
Yeah, you want
I just hate that.
I was
Now,
going
down
for
here, she
food
make
for
us turn
that.
on cameras on for a break.
Really? I should have did that.
No.
Every time we do it, I'm like, hey y'all,
They ain't had two
turn your cameras on.
You used to do
weeks.
that.
Boom.
I just been affected. If you don't turn your camera on, you get marked out. That is so childish. That is childish.
Why are you so funny?
That's childish. You never made a time for me.
I don't even want to see y'all, to be honest.
Yo, you need to put some food on the grill, bro.
Get out my face.
What is going
You came over here and sat over here by me. First off,
I'm like, are you
give the
serious?
little blanket tail back.
Oh, God. Oh, seriously. Hey, I don't know.
I forgot.